we are summing this is a telescope sum. So let's do that. So we have k equals 1, then 6k, 6 to the power k going to infinity, 3k here minus 2k here, right? Then 3k plus 1 minus 2k plus 1 here will just be equal to, so this is basically going to be 6k here, then we have 3k minus that. Now what we are doing now is to apply partial fraction, right? So we are applying partial fraction over here. So 3k plus 1 being equal to a divided by 3k minus 2k here. Then we have plus b here. Then we have 3k plus 1 minus 2k plus 1 here. So since we have this, we only take the numerator, right? This will be equal to 3k plus 1 minus 2k plus 1 here. Then plus b here. Then we have 3k minus 2k. So solving this, what we have here, so we can just expand this. So we have 3k plus 1 multiplied by that minus 2k plus 1 here multiplied by a. Then we have 3kb here minus 2k, then also b. So what we'll do is to group like terms. So we have the powers, the base 3 here, and we have the base 3 here. So we have 6k here being equal to this and that. So we can have 3k out, right? You can have 3k out. So we are going to left with just 3 here with a, then just plus b. Yeah. So then in the second equation we're going to get 2k, we're going to get 0 being equal to so we take the second equation for that is 2 base and the 2 base here. So we have minus here, so we are going to get minus here. So this is going to be minus and this is going to be positive. So we have minus b here, right? So in the second part we have the positive part being so we can actually bring 2k out, then we are left with 2a, then we are left with b. But remember the 2k over here is negative, so we have negative here. So let's call this equal to 0. Let's call this equation 1, equation 2. But then also we can have the equation in this way also. So we can have this equation. Let's call this one a, and we can still have the equation this way also. So 3a minus b being equal to 0. 3a minus b here being equal to 0. So what we are doing is to change this part. So we can either have this or that, and we can also have just 2k here minus 2a plus b here being equal to just 6k. So we can have these two equations, and let's call this one b. So for a, so if we take the a part, we realize that we just have 6k to the power 3k here, then 3a minus b. So what we can do is that we send the 6k and the 3k here, and we have 3a minus b here. So we can have 6 over 3 to the power k, right? 6 over 3 to the power k being equal to 3a here minus b. So this is just going to be 2k here equal to 3a here minus b. So this is just the equation 1. Remember the equation 2 was just that 2k here, then we have minus 2a plus b as the equation 2. That is for a, right? So we are doing that for a. Okay, so from here now let's write the equation 2. So when we send the 2k down here, we are only left with 0 here being equal to negative 2a plus b here. So let's call this one the equation 2. So comparing these two equations, right, realize that when we sum them up, now negative positive, so b goes away and therefore we can calculate for a. So summing them, we have we'll be left here with 2k here being equal to just a, right? Just a, right? And if there is a case, then which means that b here, let's make b here the subject. So so we have a here equal to, so a here equal to 2 to the power k. Now from this equation we have b here equal to 2a, right? So b here will be equal to 2, then b multiplied by 2 power k, and we have this as just 2k plus 1 as b. So b here is equal to that, right? So we have the value of b and a. So from here, from the sum or from the first part, so let's say for the first part we have for the first equations, which was the for a, we had a to be 2 to the power k, right? A to be 2 to the power k, but then also then that of b here to the power k plus 1, right? So we can have for the first part. Now for b, right, for b we have 3. For the b part, we said 3 power k, then 3a here minus b here should be equal to 0, then 2k here minus 2a here plus b is equal to 6k. That is for the b part. So we are going to get so let's send this to the other side. So we have 1 and 2. Now for the equation 1, we are going to have 3a minus b being equal to 0 for equation 1 when we send this to the other side. Now this goes to divide that, and we have just we have minus 2a plus b here being equal to, so over here we are just going to have 6k divided by 2k, which is just 6 over 2 all to the power k. So we just have 3k here, right? So we have 3 power k as equation 2. So over here too we sum, right? When we sum, b goes away and we are left with a being equal to 3 power k, right? And then also b here is just equal to 3a. So therefore b here will be equal to 3 multiplied by 3 power k, and therefore b is equal to k plus 1. That is for the second part. So we have the b here, the second part, right? We have the second part being 3 power k for a, then b here being 3 power k plus 1 for b, right? Okay, so if that is the case, then we can then substitute this into the general sum. So the general sum was given us so let's write the values of a and b, 3k minus 2k here. So we only take the first part, then do that. So k plus 1 minus 2k plus 1 here. Remember we said a, right? It was a being divided by just 3 power k minus 2 power k. Then we also had minus b here, b 3 power k plus 1 minus 2k plus 1 here, right? So from here, since for the first part we had a to be just 2 power k, right? divided by 3 power k here minus 2 power k, right, minus the b here we had 2k plus 1 here being divided by 3k plus 1 minus 2k plus 1, right. So putting this into the sum, then we can have that so we just have the summation of k here being equal to 1 6 power k here being divided by 3k minus 2k, right, 3k minus 2k, then also 3k plus 1 minus 2k plus 1 here will just be equal to, now we have so that's for the first part. So we're just going to get for k equal to 1, we're just going to get 2, then over here we just add 3 minus 2 here, then minus, so we apply the limit as k is approaching infinity, and realize that for this part, right, so put it for that part, k plus 1 here being divided by 3k plus 1, then minus 2k plus 1, then we are just going to get this, all of this goes to 0, and we just have 2 here as k. So sorry, we have 2 here as the sum of all of that, and that will be it for today. Thank you very much for joining me in this section, and I'll see you in another section.